So.
Yeah, that all works. But as everybody kind of knows who you are, I'm just gonna give the word to you pretty
All
much
right.
from
Okay.
the
Thank you.
get-go. All right. Good day, good afternoon, good evening, everyone. Welcome to another session of Amplifying F Sharp. Recording is running. Wonderful, got it. So, hello everyone. Today we have Don Syme. I don't think he needs any introduction, so over to you, Don. Kick it off.
Okay, thank you, Florian. It's nice to come into amplifying F sharp. I promised to give a session a long time ago, and yeah, I mean, I've you know, it's wonderful to find ways to contribute to the F sharp community. F sharp community is very, very dear to my heart, and obviously F sharp is dear to my heart. And I've sort of my responsibility in the F sharp community these days is to kind of give a top level, well, not top level, side backup kind of for lots of some things that go on for the F sharp language design. It's not that I'm active in the F sharp language design at the moment, but I kind of hold the keys to give the responsibility over to other people like Thomas Grossup and other people in the community who are driving the processes along. And although I'm not kind of actively driving that along, I am kind of there as a backup for some of the things that go on in the community. And yeah, but my own personal research work and technological work has, like a lot of people, in taken a much more AI kind of direction. You know, we have this incredible change going through the software industry, and F sharp is kind of a reference point in my mind, both for as AI changes how software development proceeds, I kind of always referring back to F sharp, whether at the technological kind of level, the programming language level, or whether it's about how uh, sort of there are responsibilities for how much does the compiler kind of check in ensuring software is well formed, or how much the kind of AI or how much the CI/CD kind of processes will be kind of checking how things are well formed. But I also think about it at the kind of community kind of level as well. How will AI kind of technologies kind of affect F sharp developers? And I mean, my aim all the way through with F sharp has always been to empower developers, and empower developers to be more productive. And I think F sharp has a particularly strong sweet spot in taking individuals or small teams of aligned individuals and making them hyper productive. They are able to solve problems in the kind of functions plus data plus types kind of simple kind of mindset, and absolutely crank out solutions to problems very effectively. AI enhances that incredibly. If the use of coding agents in the context of F sharp development is extremely effective these days. And so I've always taken a productivity kind of mindset. I've always thought that teams of 2 to 3, 6 F sharp developers could compete sometimes with things that were created by groups of 5, 10, 20, 30 developers. And that, I think, approaching AI with a productivity kind of mindset, rather than all this kind of question about like how are jobs going to be affected and so on, but just say, how does it actually make us more productive as developers and as teams, is a kind of fundamental mindset that I kind of like to approach the question with. I also kind of approach a question of like how AI is going to play out from there is so much important work to be done in the software industry. When I look at companies who have, say, 2,000 production systems, like some banks that I've worked with, for example, or I've seen how software, how much software has been created in the software industry, and how much legacy there is, and how much analysis is not being done that needs to be done. So I don't think of it as kind of a fixed amount of work that needs to be done. There's actually just this absolutely vast amount of work that should be getting done if the costs, if productivity can be raised and software engineers can be made more productive. There's more and more work to be done. So I think by reducing the costs of getting the kind of software development work done, we can actually make the whole software industry better. We can end up with better software. We can end up with more of that legacy and technical debt being dealt with. We can end up with higher performance software. And that's some of the background to what I want to talk about today. So I want to kind of give a direction for what we've been cooking up at GitHub Next. And let me just share my screen and talk through some of this. So the shaping of this, and I'm going to use these slides here from a talk I gave last year, which is about towards semi-automatic agentic performance engineering. And the first place I came and applied this to was F-sharp libraries. And I've been wanting to talk about that application of these techniques to F-sharp libraries. I had been hoping to kind of revise everything and do it all over again on those F-sharp libraries. I didn't quite get that completed this morning, but I got some bits of it done. My mind, I'll show you what I was tinkering around with this morning. But this is a snapshot of work as was about November last year. It's a very fast-moving area, and the sort of style of work that I was doing here is now becoming quite commonplace across the industry. Okay, so I'm at GitHub Next, and we are a lovely little research team of about 15 people who are kind of tucked in close to the GitHub product and office of the CEO at GitHub and the like. And our job is to kind of take things forward in software development. We've got a pretty broad remit. We're kind of half, I'd say, front-end people and half back-end people, where I would be on the kind of back-end side of that. Okay, as I said, we live in these incredible times. They're somewhat disturbing times because things are changing so fast. AI, indexing, and also just traditional dev tools, they make us all into absolute magicians when it comes to code. This is a slide I use to first years at King's College in London, where I have a professorship. And I just want to, I like to get across to the first years that they have the power in their hands, especially through coding agents, that it's not something that is actually kind of to make it a little bit more personal for them, that they actually have that truly quite magical power. We're seeing these coding agents being able to implement functions, as in logical functions like code generation, for example, that we just never thought would be ever possible in computing. But things can go wrong, and I'm not a huge fan of Rings of Power as a kind of Lord of the Rings kind of thing, but it does have this great portrayal of Gandalf as the kind of younger Gandalf learning like the usual magician kind of thing. These things can kind of blow up, and it comes with great power along the way. And that's the kind of framing I mean about productivity or magic or effectiveness. But there's a lot of things that can kind of go wrong along that kind of path as well. And this is the way I kind of look at dev tools in terms of AI in the kind of their history. And it's my framing for a kind of historical mindset. We don't have to care too much about what went in the past, but sometimes it's kind of useful to kind of see how things have evolved in order to maybe get an idea where things are going. And so 2022, we have kind of AI for completions, and that is now very, very widespread across the industry. I presume nearly everyone on the call will be using this in some form or another. 2023, there was just a lot of playing around with like, what are other kind of factorings for using LLMs in the context of AI development? There are a lot of prototypes around of, say, test generation or summarization or advice or code review or IDs. Now, I wouldn't say anything really huge landed in that, but 2024 was a huge year. We did a prototype, which was influential, called GitHub Copilot Workspace, and that introduced the idea of task-oriented development. And the people who really took that forward at great pace was Cursor Composer. They added in some, they brought the task orientation idea and took that into the IDE and made it very, very fluent to kind of use this kind of coding agent, kind of agentic kind of thing as you were working with in the IDE. There were other automated tools like one called Devon around that time. And then 2025, we saw the first coding agents in Claude Code, sort of CLI-based or coding agents. And we also saw lots of other catch-ups. And then in terms of VS Code, having a thing called agent mode, which is what I tend to use for my IDE integrated AI experience. And then in 2025, we also saw a big investment in AI for app development, app dev. We saw things like GitHub Spark or Bolt or Gemini or Lovable companies taking a different approach. One I've been interested in is one called Cogno in London. And now, where do I think things are going? I mean, I think we're seeing my prediction as of late last year was it would be headed towards what I'd call proactive or continuous AI, and effectively automation. And I think with OpenClaw, we're kind of seeing that. It was slightly different than I was predicting, but we're kind of seeing this notion that AI assistants should be much more integrated and much more proactive in either the with OpenClaw, people are trying to do it in kind of their personal life, sending messages for themselves. That's not quite the direction I personally go in. But in our work, we're looking at this sort of proactive AI assistance in the context of repositories and in the context of what we call, in the direction we call continuous AI. So let me just talk a bit about that. So about May last year, we put together this, it's really a concept page about trying to kind of formulate a term for the industry to capture what will happen in the coming years. And if we think of continuous integration and continuous deployment, they're hugely influential concepts in the industry, CI/CD. And to me, they're like two legs of a stool, and the third leg is now continuous AI. And it's a different leg. Just like continuous integration is different to continuous deployment, continuous AI captures a whole lot of things which are additive to that. They don't replace what is done with integration and deployment. They're sort of, most of the things are kind of integrative in that there's change kind of going along and AI is kind of assisting with that kind of change. So we coined this term. It seems to be a term that resonates with people. We deliberately made the term neutral and they're not associated with any particular technology. We want it to be aligned with CI/CD kind of systems in the thinking, but we didn't want it to be like GitHub Continuous AI or something like that. Of course, you have to give that a term like that some meaning. And so the way we did that was just to kind of say, well, what might we mean by that? Certainly, continuous documentation can fit into that. That you continuously populate and update documentation, offer suggestions for improvement. Continuous code improvement is an interesting one, and one very close to my heart in why I'm kind of doing this work. And it's what I alluded to earlier about there's so much improvement that needs to be done in the industry. There's so much, frankly, to use the word shitty code out there, so many broken repositories, so much small improvements that can be made, so much technical debt, but actually just improvement. And in a way, if you look at the design of F#, so much of it is about improvement. Like how much can we just make coding as we saw it in the .NET world better through the use of functional kind of techniques, better through the use of strong typing, better through the use of a simpler mindset in functions and data rather than sort of the endless object-oriented kind of fairyland that was around in the late 90s and early 2000s that influenced kind of the other direction for F#. But there's a lot more than that. And one area, for example, we're seeing a lot of interest in for kind of enterprises is about fault analysis and fault investigation. When you look at the engineers at GitHub, I mean, they work very hard on their code, but they work very hard on achieving well, we don't always achieve it, but achieving the level of quality that quality and reliability and availability that we need. And of course, underlying that is fault analysis. And so when things go wrong in the GitHub system, if the coding agents can have proactively investigated what is going wrong, or if something goes wrong in your repository, if a CI run fails, then it's quite a lot of work to kind of go and say, well, why did this CI run fail? And not only that, but kind of actually do an investigation and prepare a pull request to kind of fix things. And if that can all be done proactively, that the analysis is already there, and possibly even the fix is already there before you've even really come to look as a human to come and look and check what is going wrong, then that can massively improve efficiency. And again, it's in that category of work that needs to be done, extra work that needs to be done, that is purely assistive and augmentative and isn't being done proactively or fast enough, and overall should, done well, increase the overall productivity flowing through the system. Okay. You can also enforce kind of coding standards or take code bases in particular directions. And there's another area, which is there's these areas of development which are kind of orthogonal, like an accessibility for front-end development is one of those, where you actually would just want to sort of automate the checking and adding of accessibility annotations. And it's kind of routine, but you kind of need an expert in that kind of field. You can't afford, it wouldn't be possible to afford an expert on accessibility for some of the kind of software that, say, the F# community people work on. So why not automate that kind of side of things and have something that automatically checks and improves the accessibility of code and documentation? Okay, so that's the kind of ideas about continuous AI. You can get the idea that these are automatable, repetitive. They're often collaborative, and because we're GitHub, we're taking a much more collaborative point of view on this. You want them to integrate into existing repositories or workflows. It doesn't have to be GitHub, but it could be something else. And there's a lot of proactive kind of event-triggered kind of stuff going on. And another thing that really interests me in this is it's like GitHub Actions in the sense that there are many, many variants. And there's a lot of people who would propose first-party solutions to this. That, for example, a platform like GitHub or GitLab or something like that should have a kind of automatic documentation kind of tooling as part of that kind of platform, and that's fine. But what I'm interested in is the really long tail, because I want the power to be in the hands of you. I want you to be making the decisions about what matters for you in the repositories where you are, generally speaking, maintainers or have write access or contributors or part of a core kind of team, or what matters in your enterprises. Rather than saying there's one right or wrong way to do this. And it's also embracing that kind of open source dynamic for, there'll be lots of variations of these created, and lots of them will go the way of things in a kind of Darwinian kind of way. And there'll be really great variations on these which do last the test of time, and patterns that last the test of time. And part of our job is to explore this space, but we want to explore it with you in real repositories. Okay. So, of course, that we need to actually make a technology that actually embodies the principles of continuous AI. So I've talked a bit about that. And you can actually see continuous AI as the natural partner to completions. The completions is about putting AI into the inner loop of software development. Continuous AI inner loop, as in being the loop the developer sits there in the IDE, the most concentrated point of their whole working life. I actually would never have believed we could inject AI assistance into that kind of space. Of course, someone from the F# community, Christoph Chislak, is absolutely been involved in that kind of getting AI into that kind of GitHub Copilot kind of completion kind of space. But there's also what we call the outer loop of the SDLC, the kind of the CI/CD kind of loop, the loop that actually deploys and actually checks the kind of final software. And both loops are going to be around, but it's by the nature. I don't think that we're just going to see complete convergence to kind of the IDE, except in some areas of software development we might, but in we know that in enterprises and the outer loop is going to remain extremely important, and in open source software as well. And so yeah, continuous AI is about how does AI fit into that kind of outer loop kind of process. And I've covered most of this. I will just introduce a term here, which is, we've got the DevOps term that kind of matches CI/CD. You could look at AI as a subset, like a subdiscipline of DevOps, so continuous AI as a subdiscipline. But in reality, I think what we're going to see is a new class of job, effectively, which is sort of agent ops kind of developing. And I think it's, as we all think about how this influences what our working lives are going to be like, I think that's a useful North Star to have about the kind of skills you can be looking to augment your CV with. I've in some aspects of this, you don't just have to be an expert on AI. You can be expert on continuous security or continuous documentation or an agent ops or continuous agent improvement, monitoring and learning, and so on. And you don't have to give all of these things over to a platform either. You can have technologies that actually empower and enable you to do these things. Okay. And I've run through some of these: proactive, automatable, repetitive, collaborative, integrated, and auditable, and org project specific. Right, AI for collaboration. And okay, so let's talk about what we've actually put together for actually doing continuous AI. Not sure why I can't remove this little, there we go, banner. Okay. And that is a technology called GitHub Agentic Workflows, and it's just gone into technical preview. And we'd love you to try it out. I will kind of run through how you can try what it is and how you can try it out. Let's take a look at what it is. So I'll use this slide for that. Okay, so here is an agentic workflow. And as you can see, it's got a trigger at the top, and it's very, very similar to GitHub Actions. And the idea is you put, just like in GitHub Actions YAML, you put a YAML file in the GitHub Workflows directory, and it just runs. And the same idea is you put this file in your directory, and it just runs in the same directory, GitHub Workflows. Now, you do actually need to convert it into a YAML file. That's really not, it's not really compilation. It's more like hardening the workflow. It's taking the content that's here, and it's turning it into a YAML file where the prompt is kind of embedded in that YAML file, or it goes back and reads it from this file. But it adds in lots of scaffolding around the execution of an AI coding agent in GitHub Actions to make it safe to run an AI coding agent in GitHub Actions. So this is the spec, and it's converted into a YAML file, and it runs. Okay, in GitHub Actions, just like a regular action. That means it's got a trigger, just like all the triggers you're used to in GitHub Actions. Now, a new concept that's developed here is that it has these things called safe outputs. And that's because the coding agent, the agentic step, which is this markdown down below here, runs read only. It does not have write access to your repository. In fact, it doesn't have write access to anything at all. It is like, all it can do is deliver a package, which is the safe output. It's basically a plan apply kind of model. And it's actually quite giving a more functional, or at least, a kind of mutable kind of approach to how we use coding agents in the context of automation and repositories. Because of course there are concerns about automated coding agents. You've got automated agents having write access to things. you've got trouble. Okay, so you want to have automated access with extremely guardrailed, limited, anchored operation. And in this setting, all it can do is create an issue, and all it can do is create one issue. It cannot. If you look at other variations on this kind of pattern about like automating the use of coding agents in GitHub Actions or in some setting, you'll see that they allow arbitrary write access to your issues. But just have a think for a moment what that could mean if, for example, the operation of your agent code, your coding agent went automated coding agent went astray. It might it might close all the issues in your repository. It might delete the content of all your issues in your repository. It might spam or every issue with comments. It might create 1,000 issues. Okay, so that's a way overprivileged. So we want to corral and constrain what the automated coding agent can actually do. And you give it some tools, say web search or web fetch or something like that, and then you give it a prompt. Okay, it's nice and GitHub Actions friendly. You can have these substitutions in the middle of it as Actions familiar, and but really it's a form of natural language programming. And if you've read my blog entries, there's nothing wrong with natural language programming as long as you've got an engine that which is an agentic coding agent, which can actually take these instructions and actually do something generally speaking, do something useful with it. In this case, the aim is that it's each week, this thing is going to run once a week, and it's going to do research into your repository and into the industry, and it's going to tell you it's going to read some of your code. It's going to understand your project. It's going to read latest news and trends, and it's going to write your report. And actually, this is actually really useful for, say, competitive analysis or related kind of projects. Or if you're working on an F# library, it might be like, well, what are some Scala libraries that are actually kind of similar, or what are some Clojure libraries or C# libraries? You can get it, and you can, of course, the prompt is under your control. You can shape this in any direction you want to get these automated reports coming out. Okay. The way this works is you're assuming like GitHub Actions YAML, it is running in the context of your repository on GitHub. So it's very much what we'd call repository automation or AI-assisted repository automation. Okay. You might want to have a different one that triages issues like this, so that every time an issue is opened or reopened, you analyze the issue and then add a comment to the issue. This one, you might also want to add labels. There's actually, this isn't quite well formed because the safe output doesn't declare that it's allowed to add labels. There is a safe output for adding labels to issues, and that should be there in that safe outputs list as well. Okay, so ultimately we just wanted to add the markdown and the agentic workflow just starts working. But in reality, you have to transform it into what we call the lock file, agent.lock.yaml, and then the agentic workflow starts working. So in order to do that, so for example, say a F# library that I'm maintainer on, we'll see that in the GitHub workflows directory, we have some workflows. And you can, let me open that up. And we're looking at GitHub workflows. So this daily performance improver workflow, or we could create a new workflow. I'll actually just run through, and why not grab this one. Here, I will save that as weekly researcher.md. And there is an extension which you can install by doing install github/ghaw. Okay, it's already installed. I'll just check it's up to date. Okay, and now I can do ghaw compile. Okay, so there's some warnings. Actually, Copilot, which I'm using here, doesn't support web search, but you'll see that weekly researcher here has actually been converted into a lock file, and I can status. I can just add those two files. Workflows, origin, main. Okay. I'll push those directly to main here. And now over in the library here, you can see that we now have our which one was it? Agentic Weekly Researcher, and I can just trigger the run of that workflow now. Okay, so that's adding basic agentic workflows, and let's take a look at doing some more interesting things with these kind of workflows and some of the principles here. Okay, so design principles, Markdown is actions familiar. The default is simple. Emphasis is on the natural language Markdown. It's a little bit like F#. You want the content of the programming, the kind of domain focus to kind of come to the surface, not all the rest of the kind of YAML scaffolding that is ultimately needed to run these things. And we do assume an agentic mindset, that is the Markdown, the natural language, is processed by a coding agent that has access to some tools, which are usually MCP tools. It can also use Bash along the way. And it can include shared components. You can have libraries of these things. You can start to develop these things and share them with other people in the community, and they can install them and update from source and so on. And it's all about safety, and that means execution is sandbox, but it's actually doubly sandbox. We've both got the GitHub Actions VMs, but we actually run these agentic steps in a container of their own, where they don't have access to any tokens or other things that are normally available on an Actions VM. That might create problems when building and executing certain kinds of code. We do have tests to check that .NET code is just fine, and all the major ecosystems are just fine in that extra container that is used. You can turn off that extra container, but you lose some of the safety guarantees. If you turn off the container, you're back to much more of a kind of GitHub Actions kind of world that you might be normally used to. The permissions, yeah, as I said, minimize. It runs essentially read-only. All outputs have to be in this kind of safe outputs kind of thing. And we do have, that container is firewalled for the outgoing network as well. Now, you might say, why do you want to firewall the container? You know, we don't normally firewall things in GitHub Actions. There are good reasons. If you're in a private repository, you don't really want your agent to suddenly decide, hey, I'm going to send your code outside your kind of organization. So that's a good reason to have firewalls. Another one is if you're processing data from third parties, they might attempt to, like issues, for example, which are created by anyone. They might attempt to point your coding agent at a dodgy script or to which may be hosted on some sort of dark web kind of website. And so you don't want that to be a normal kind of thing. So having some degree of firewalling of the agentic step is usually appropriate. You can, again, turn that off if you like, and you can add extra kind of allowed websites that it can access as well. Okay, so GitHub Actions is a good place to be doing all of this. It's a natural thing to do to kind of, it's a place that knows how to restore, build, and test your code. And just to say, these workflows can combine, I focus mostly on this agentic step, the coding agent step. They can have deterministic steps for beforehand, and they can have custom safe outputs for deterministic steps for the outputs as well. So you're in control of both sides of that. I'll just take you through, show you a design pattern about how that plays out in practice. So in our docs, I've more or less ran you through the kind of quick start for the doc process here. The quick start we actually show is a little bit different in that we use this ad wizard to help you get your secrets set up. You do need a token at the moment. There is an integrated billing for this on the GitHub platform as yet. You can use Claude. You can use Codex. We're adding Gemini support. We're adding Mistral Vibe support. And it's all open source, so you can come and contribute support for your own favorite coding agents as well. We will need a token of some kind to be able to run testing for that, but you come along to the repository and help add more support for more coding agents. In this workflow, we actually add an existing workflow rather than kind of I cut and paste and did a manual compile. And that existing workflow is a similar kind of thing, which is called the daily repo status report. It's very similar to what I kind of showed. In this case, it's for a maintainer to kind of, you can imagine a maintainer getting a big flood of issues and pull requests into their repository. We're working with people like what is it? The home automation platform, Home Assistant, I think is it called. So these people are one of the biggest open source projects on GitHub. They have thousands and thousands of issues in their repositories, and they need, in a sense, there's a lot of work that needs to be done for the maintainers that isn't really being done because, as we all know, maintainers are under kind of a lot of pressure for the floods of stuff that they get kind of coming in. Okay, so where was I at? I was looking at, yes, this one, this daily repo status. So in this, okay, so that's the quick start we show, is adding that through just this kind of add command. If you're interested in creating your own workflows, you can just do them by hand. Like I said, I think it's an important exercise to kind of go through to do it by hand so you can understand how it kind of works. In truth, a lot of people using this, just like everything in this, they actually use AI to help them create the workflows. Now, you can do that in your favorite coding agent. You can sit there in VS Code and add in, create me a workflow. You can say, go read the docs on how to kind of do it, or read. But there is actually a fully kind of pre-baked thing where you can actually just kind of walk up to a repo and say you can walk up to this kind of repo and you can come to the agents tab in this repo and you can just kind of paste this in. I want a workflow for triaging issues. Is to improve the testing in this repo daily or something like that. You can kind of type that in and then you kind of submit that, and it will actually go and do the business to create a workflow, and it will do the compilation of the workflow. So you'll get the lock file checked in for you, and then you've in a couple of clicks and a couple of steps, you've got an assistant in your repo helping you do your work. I did that earlier. I haven't actually tried this before. I mean, it's sort of been on my mind as part of a background is what is it like to actually have a co-maintainer in a repository that kind of this is a little bit overprivileged on this one. I said I'm not sure we will stick with this, but just to give you an idea, I was just checking that the path worked. So I walked up to F# control.async seek and I said, create a workflow using those instructions to act as a great repo co-maintainer. You don't really want co-maintainer. You kind of want like junior maintainer or something like that. You don't want it actually doing anything for you. But I did say, you're allowed to comment on issues. That's probably overprivileged. You don't. At least it should be really declaring, hey, this is AI assistance. I might get things wrong. Don't take me too seriously. But I did say make it that it could work and fix issues, make it study the code base, keep a memory about how what's been tried. So there's the memory mechanisms, always be playful and helpful, and keep in mind the overall goals of the repository. That did come through, and that creation of that workflow kind of completed. Let's have a look at this workflow here. And it created, but let's double check what it created. It said, okay, it's sort of following the instructions. nice description. It said it's going to schedule every 4 hours. That's correct. It chose a set of safe outputs that should match what it said. It can add a comment, so it can't create. It can create new issues and it can create pull requests. And you can see the tools it's going to use here, and you can see the initial steps it does here. So let me just increase my size here. And then you can actually see the description here. Always be polite, keep some memory, triage and comment on existing issues, fix issues, study the code base, and some information down below. Now you notice that because it's one of the interesting and recurring themes in this is that as you add in agentic automation into a repository, you're in a sense fitting it to the repository. We took a concept of a co-maintainer or of a test improver, and we said, and it's created one for you, but it's created one that's a little bit more specific. It's one that knows which repository it's in. It knows which programming language it's working with. It knows, how things work for that kind of programming language, how to do build. Now, there's a theme here that the more tooling you add, you're also creating a burden, in the sense to maintain this over time. If you switch to a different programming language, that would need to be, maintained over time. So there's always this tension here between fitting things closely, making them more specific, probably making them better, but also creating some burden and losing some generality. And that's a basic kind of tension in this kind of space that you should be aware of. But that looks pretty good. I triggered the execution of the action earlier on. We'll just see what it did here. So this was the run of the repo co-maintainer here. And you get, now, of course, I love this about this, the fact that we're on GitHub and we're on GitHub Actions. You get these, you get a full audit of what is going on effectively, a full trace. You can see the full prompt that was being used, and then you can see what the coding agent actually did when it ran. So let's take a look at what it did. It looked at the issues in the repositories. It's poking around to see what actually issues are actually active in this repository. It's reading some of the issues. It's actually multiple of those. Read about 4 or 5 of the issues, and it kind of did some poking around about one of those issues to say, maybe I can kind of fix this. Maybe I can kind of help with that. Now it's understand the issues. It's kind of worked out this and this and this. And then it has continued on with its work, and has built the code, and it's actually going to propose a fix for one of the issues. And then it's working out how to actually create a pull request. It shouldn't need this many steps because it actually it actually should step straight to this thing here to actually to create the pull request at the end. And then it adds some comments on some issues, and then it is done and it updates its memory. Okay. So when we look at that, we will see that first of all, it's posted some comments on issues about how to do various things. So for example, this was the issue it really went and looked at. And I would want this to be clearer that this was from an automated AI assistant. And again, I don't even know if this is a good idea to actually automatically comment on issues like this. At least, you have to be very careful with this. So it did do the analysis of this issue, that if we want of async enum to be supported on .NET Standard 2.0, the fix is actually just not hard. It's like previously there was that thing was guarded by if Net Standard 2.1, netcrap 3.0. It can actually just be Net Standard or Net, and then the thing will become available on Net Standard 2.0. Now, this is probably a somewhat old issue, and it's probably not even that important now. But it is of interest. And so it created the pull request for this, which was to expose this on Net Standard 2.0. It hasn't added a test here, so I would not accept this pull request on this. I'd make sure that this is actually covered, although I'm pretty certain it's a straightforward improvement. I would also probably go back to that co-maintainer workflow and say, actually, if you're going to propose pull requests, make sure you've got the testing, make sure you've run the tests, and so on. So we would improve the agent. Now, the other thing you saw me do was to add a daily test improver to the repository. I did that agentically using the agents tab that we saw earlier on, and this is the result of doing that has come through now. It's a similar kind of thing that it's allowed to create discussions, comments, pull requests, and issues. Its job is to to improve the testing in the Agentic library. You can't merge pull requests. It doesn't have permission to, you can tell from the safe output that it doesn't have permission to merge pull requests anyway. And then similarly, you can see that its job is to try to implement some kind of test improvement and run that in the repository. A very similar kind of thing as you can see with the project context and the like. Okay, I'll just add that just to, so ready. I'm just going to add this. I'll clean this up afterwards, but just for the purposes of the demonstration, I will add this. And I'll just trigger a run of that. I'm not certain it's going to do anything useful. Where was it? Yeah. Daily test improver was the one we just added. That one. I think that one. Let me just check the name of that one. Make sure we got the right one. Workflows. 5 minutes ago, daily test improver. That's the one. Welcome to actions. Daily test improver. Run workflow. Run workflow. Okay, we'll set that running and see if it does anything useful. Okay, so I said that these agentic workflows could combine hard and soft steps, and that is covered actually in one of these. We've got this great set of design patterns, and if you're interested in this space at the kind of, as I guess most of you will be, at the kind of conceptual level, or how is this, what do I need to take forward in my career, then this design patterns is it's a really good list of things to kind of work through. And they covers things like what we'd call the sort of basics, like how might you set up automated flows that work with issues or work with labeling issues. What about if you want workflows that work across multiple repositories, not just this, or where you have a side repository, so you don't touch your main repository, but you still have a side repository where the action is happening. Those are interesting patterns. Another is what we call data ops, and this is what I was getting across before, that you can have workflows that combine deterministic steps, which are, say, collecting data deterministically and efficiently with sort of deterministic data extraction of maybe the titles of thousands of issues, for example. Or titles and labeling of issues or something like that. And then you can have an agentic step, and then you have your safe outputs kind of step. And so just to give an example of that, here you might have some steps which fetch all your recent pull requests here using what you would expect, and then compute summary statistics like this, and then actually do the kind of agentic or soft, or these agentic steps, you should think of them as like things that require judgment, things that require language analysis, okay? You can have, there's still absolutely a room for lots and lots of accurate deterministic programming, and then you have these steps which require judgment, like how to summarize activity in a repository. Okay, so that's getting to this point that you can combine hard and soft steps, deterministic and agentic. Okay, so one thing that agentic workflows enables is you to take an almost maximalist point of view on using agentic automation in the context of your repository. I don't think most people are going to be doing this, but it's a super interesting experiment to kind of just max out on agentic workflows. Like, do you need just one to do that? Like improve my repository or be a good dev in a repository? Or do you need hundreds of them? Where does it kind of land? What are the design patterns that kind of come along the way? So that's been part of our research, and we've put that together in what we hope is a fun and kind of humorous way. My co-collaborator in this, one of them is really, in many ways, the lead technical leader on the project now, is Peli DeHalio. He's from Microsoft Research. He's awesome, awesome guy, wonderful, very, very creative, and in his use of agentic coding in repositories. And so we took the approach of maxing out, let's create a new automated agentic workflow for just about everything. Okay, now it's going to be expensive, but it's kind of ignoring costs for the moment, but it's saying because costs are coming down in this kind of world, if you look at, there are great models that you can run pretty cheaply. Okay, so what is Peli's Agent Factory? It's like hundreds of agentic workflows that we use ourselves in the repository. We use them to triage or diagnose CI failures, or they're similar categories to what I was talking about before. And that's kind of showing that those categories that we talked about are actually real. You can actually come in and look at actual real workflows and what did they actually do, how are they written, what features of the framework do they kind of use, and and sort of get kind of ground that in reality. And we've got this series called Meet the Workflows, and so, for example, you can look at these kind of continuous improvement kind of ones or fault investigation ones and kind of dig into those. There's a couple here that I'll run through the continuous ones because I really like these ones. And I like in the design of F Sharp, I like simplicity, right? I like code to be pretty dry, not completely dry, but I like code to be simple so why not have an automatic code simplifier that looks at recently modified code, recent pull requests, and say, could that have been simpler? And what we see here is that it's also maybe part of the answer to AI slop in repositories. That the front end of development, the front edge of the development curve can be humans using AI, agentic assistance without worrying too much if they've maximally simplified the code. Because running along behind them is a code simplifier, which is looking at their work and saying, actually, that could have been a bit better. That could have been a bit simpler. And here's my improvement to kind of run along behind you. You can also have workflows which include a deterministic analysis, and they can actually get the full call graph of the code, and they can look, for instance, for duplicate code, or they can try and reorganize the code to be better organized. It's something we're all used to doing as devs. You can kind of automate that kind of those kind of processes behind. Some of the analysis here has stats on our merge rate of like 5 out of 6 of those merge. This was a relatively recent one, and links through to actual examples of the simplifications it did. And you can kind of click through on those to our repository to see what that code simplifier did to help things move along. And I think as experienced devs, and I think as devs with the F Sharp kind of mindset, there's a lot of good things we can bring to the industry by taking the point of view that F Sharp brings on how relatively simple and clean code can be, and bringing that through into these kind of automated processes. And of course, they need supervision by experienced and talented developers. Okay, so a similar one is continuous refactoring. As you know, F Sharp compiler, I'm very, very guilty of this. Huge files. I understand this. And it's a lot of work to split up those files. AI agents can actually split up files pretty accurately these days. They can do all the legwork that's necessary to write the signature files for the interface files for those and break things apart into clusters that make sense and so on. And so we use one of these, a large file simplifier that just splits up files and makes them into nice units. We also do this semantic function refactoring to kind of cluster together agent code into nice reusable kind of sensible clusters of these. And you can look at the merge rates, 112 merged PRs out of 142 from the semantic function refactoring. Finally, I want to skip continuous style. That's more of a front end kind of thing. And we will talk about continuous improvement. And there's three really interesting ones here. One is the Go, what we call the dependency enthusiast. And so it doesn't have to be specific to Go, but the point of this one is really interesting. It says your software already depends on some modules. Say it depends on the async library from some TypeScript or in F#. Are you using it well enough? Could your code be making more use of the things you already depend on? It's an interesting thing. Nobody's doing that in the industry, but it's clearly a useful and interesting and valuable thing to be bringing to improve software. And so it is really intelligent about how it does this. It's kind of this one of these kind of cleanup things that runs along behind you and just says, man, you could be making better use of the libraries you already depend on. Again, you can kind of see how this actually works. It's actually an analysis workflow. It doesn't propose a pull request. It proposes an issue that says, hey, you could improve this. So for example, it reviewed our use of the action lint thing here. It wrote a report and it said how we use it. And it said, here are the improvement opportunities for using this particular component. Okay. The next one is very close to my heart for F#. It is saying that actually Go is a bit like TypeScript, that it is using, it has an any type, and it's absolutely awful for the correctness of your code. So why not try and clean that up? Well, so basically hunts around looking for uses of interface or any, and it again, it writes a report on that. So for example, it wrote this report on consistency analysis. It says, I found this many uses of such and such a type. And, could it be improved? And it writes this big long analysis about what can be improved and recommendations. And yeah, this is pretty accurate kind of stuff. It hasn't yet proposed a pull request. So Pelly invoked the plan agent, and the plan agent broke this up into multiple issues. It should have linked them here. This was we've improved that, but it would link the issues, and then those would go and be solved by a coding agent to actually make those actual improvements. So that's strong typing. And then the next one is, what about functional programming? Can you actually have an improver which says, actually, like, you don't need all this mutation, right? You can actually just kind of clean this stuff up. You can use that. Now, it turns out Go's functional programming support is really miserable. We haven't used this much, not because it's not a good idea, but because functional programming in Go just isn't up to scratch, anywhere near up to scratch, as far as I'm concerned. So you can see what it tried to do, but I think this would absolutely work for C# and F# code bases. It's got the right improvements underneath. You can see it had to write its own kind of filter and map kind of things, and then it actually kind of replaced some uses of, let's see, to replace some loops here by a filter, for example. I mean, it's not terrible, but it's just not great with all these explicit annotations. It also doesn't have any list comprehensions like you really need to make really clean, immutable kind of code. Okay. Right. So that's the agent zoo. And it's a mix of topics. I've shown you our particular zoo. You're totally free, if you use this framework, to do whatever you like with this kind of technology. There's lots of samples there that you can take. You can take those workflows and install them into your own repos if you like, or you can try and generalize them or make them more specific. And I think that indicates that where we're headed is sort of continuous engineering, continuous test engineering, continuous test improvement. And I've given you examples of this. There are some extra fun flags you can add to this kind of thing. You can say run this thing, but just actually run it 30 times in a row. It says daily, but I don't care. I'm going to just keep running it anyway, keep triggering those runs. There's also a sort of auto merge PRs thing if you're real, and it's called trial here, where you kind of create a fake repository to run this stuff in. And so there's some YOLO kind of mode stuff you can do. And just to say that, the first place these kind of techniques got applied is in the F# libraries. So let's take the daily test coverage improver. There's a lovely little library called FSMath in FSLab.org, and you can see that I ran the daily test coverage improver back in October. And you can see what a good job it did here. Merge, merge, merge there's some conflicted. One of the interesting things about this world is that if things conflict, you could just throw them away. Okay, it's not a big deal to throw an AI-generated pull request away. And let's take a look at some of these kind of things that it was adding tests for the vector ops here. And it's pretty straightforward kind of testing, checking that the various operators actually work and do their things. But you expect exactly the kind of testing that you would hope would be hanging around a good F# library. I think test coverage went from about like 5% on this library to about 80% by the end. It's often hard to get 100% test coverage. Inline functions are one reason you can't do that. Okay, and then I'll finish up. And just to say, there's also continuous perf engineering. So perf engineering's hard. It involves a lot of research, planning, measuring, coding, tuning, remeasuring, testing, and you don't want to do needless perf engineering that isn't worth doing. Often there are strong stability goals around in this before you actually make a perf fix. So it is, I think, quite a grand challenge. It's easier at the kind of scale of an F# library, much, much easier, because the overall perf goals are fairly clear. You want every function to be running fast, but in balancing some code complexity kind of requirements. So perf engineering is a grand challenge. The agentic workflows can do a lot of the work in this, but it absolutely requires careful oversight. We do have a daily perf improver. I'm going to be making some more improvements to that over the coming days. Roughly speaking, it's just add on the daily perf improver, and then or you can do the kind of YOLO kind of trial kind of mode. And it does a research and plan. It also does some inference about how to build and do benchmarking in the software, and then it does repeated use of dev measure report. Okay, and just to look through some examples of applying that to F# libraries. So let's take a look at the first one I did, which was to add one to the F# control async. And it's just interesting to see what it did. The very first one it did was an absolutely great fix, a bug that had been around for quite a long time, where this append operation for asynchronous sequences was actually order n squared in the memory it used. And it's creating what we call generator chains. And it did the correct fix here to replace the use of async generator append with actually kind of a generator object that actually kind of transfers across correctly on the end of its chain. So super good fix. And you can see, you would expect, actually it then just set through and day by day was working through the various functions in the libraries. So for example, map async here, It replaced the use of a comprehension here by, and again, a bespoke enumerator object, which is actually more efficient for some situations and is worth doing for primitives like these. Okay, so with that, I think we're out of time. So I will make sure I come back and I will stop the share for a moment and make sure I come back. And I'm very happy to spend, or I've gone 5 minutes over already, very happy to spend 5 to 10 minutes answering questions or opening up to any kind of community conversation. And you can ask me anything about, anything on the AI assistance or anything you like, really. Thanks. So back over to you, Florian.
All right, thank you. That was not gonna lie, that was quite a lot. That was a bit overwhelming, but it's crazy to see where all this is going. Maybe a first question for maybe my perspective: would any of this be interesting to have for the F sharp compiler itself, and then like the improvements kind of thing, or?
Yeah, look, it absolutely is. And it's on my mind. Actually, the F-sharp compiler code base it's a big code base. It takes the significant build and test at times. I did make um, some initial stabs at that. So I said we support 3 coding agents: Claude Code and Codex and Copilot CLI. It turns out Claude Code actually has some pretty strong resource usage limitations, and those are actually about time. And it doesn't like to run as at least when I was using it, it doesn't like to run over 10 minutes on the wall clock. Okay, and when you're working in the F-sharp compiler code base and you're doing some engineering in there, you probably be wanting to run 60 minutes or something like that, just to do the builds, just to do the iterations and so on. And so that limitation doesn't apply to Copilot CLI. And so I'd like to go back and what you see when build times get large and it starts, if you're hitting those clock times, is that the AI can tend to fake it. Okay, the AI can say, "Oh, I made an improvement. I fixed this bug," but it doesn't really give you any evidence about doing that. It hasn't actually built the code. It hasn't actually tested the code. It hasn't actually taken a benchmark before and after. Or it's even, you've got to, especially on the perf improvement, you've got to look at those things very carefully. And probably you almost certainly want an agent to judge the results of your, even before you look at it. You want CI/CD to pass, and you want another agent to actually double check the work of an agent, because they can blag, they can fake it, they can say they achieved things, but they didn't. This stuff needs attention. So I looked at like automatically improving the documentation. That's absolutely easy to do. An automatic documentation improver or automatic XML doc comment improver to go through and write all the missing XML docs for anything. That's absolutely totally doable. And I'd be very happy to work with anyone in the compiler. It does, because this stuff, I'm aware that Thomas, as primary maintainer on the compiler, is got a lot of work on its plate already, a lot of pull requests coming in. I don't want to necessarily kind of burden him with like extra AI. There's always this thing about aligning to what the maintainer actually needs. So rather than me coming in saying, "Hey, I got this kind of tool, we could spam your repository with lots of stuff,"
Mhm.
I want that to be in control of the people who are in the repository, who are deciding what's useful together, and having a grown up and mature conversation about like how much automation do we want to use, and where are we finding it most of value. I did. I think for those little libraries, like the ones that I'm maintainer on, I kind of keep an eye on them. Um, I felt like I was confident it was bringing value on performance, and so I was happy to kind of do those contributions there. To give an example, I worked with, there's a theorem prover called Z3 from Microsoft Research, a constraint solver, and I did work. We did some work it's a C++ code base. we did some work to try to apply automatic test improvement and perf improvement in that repository. And it was a sobering lesson because you realize the limitations of these techniques because test improvement was good, but testing is not the, you know, to improve test coverage, you often have to check in lots of stupid tests, lots of very small tests. And the maintainers didn't want that. Well, some maintainers wanted it, but some maintainers didn't want it. And so there can actually be kind of tension between maintainers about what's actually worth having in a repository or not, especially when it's come in. And there can be some maintainers who really don't want anything AI coming into their repository at all. And I get that. And again, that's why I want it to be in control of the communities that have, that have to negotiate these different kind of tensions. And then we did some perf improvement work, and that was super sobering because doing perf improvement on C++ code bases is hard. I don't know if the AI tech is really up to it at the moment. It was at least this was using Claude Code as in GitHub Actions, and it was doing things like loop unrolling that are done automatically by compilers. And you really shouldn't do that to a C++ code base because you're just going to make the code base unmaintainable if you kind of manually loop unroll. And it then, on the whole, its analysis was good, but its coding wasn't good enough, and it hadn't really run the benchmarking before and after. It was blagging. It was saying it had made an improvement, but hadn't made an improvement. So you do have to be careful on these things. The longer the build times and the more complex the code, and just because it seems to give an improvement doesn't mean it's actually an improvement. You've got to check everything. Yeah, but absolutely, I think it can be applied in the F# compiler code base, and it can be applied in any F# community code base. I think should at least have a kind of daily improver of some kind installed into it, and there are costs associated with that. That's another question. That's another big question about who's going to end up paying for this in open source repositories. Who's going to at the moment, everything's associated with individual accounts, including Copilot. So there is no what we'd call org billing for Copilot on GitHub. That is absolutely in the works. Okay, that you would have organizations sponsoring this. But equally, you can burn a lot of tokens doing this kind of analysis. It can end up being real costs.
Yeah, for sure. I can imagine the tokens running through it. We got a question in the chat. Can you see that the software industry will encounter similar transformation that went with phones from Nokia to Androids? Instead of professional quality software, we will have huge amount of more code, but compromise on quality?
Ooh, that's a good question. I mean, my point of view is that we already compromise on quality, and I said that at the start. Just looking around enterprise software development, the technical debt is of the last, the last 50 years of software development. There's just an awful lot of systems. I'd be, if it wasn't for the development of AI software engineering, I'd actually be genuinely worried for a lot of major corporations about the amount of technical debt they have. When you've got 2,000 production systems in an investment bank that's at the core of the economy and those no one knows how those systems work. A lot of those systems were duplicates of other systems that they kind of created to try to turn off the original system, but they never quite managed to turn off the original one, so they end up with two instead of just one. And then the architects, some. But these days, they can probably just set the agents loose to say, what actually are all our systems and what are they actually for? And what are our opportunities to actually retire some of these systems? And what are the concrete steps we'll need to do to that? And look back through all the historical records about why we weren't able to turn off this system in 2013 and what workload does it continue to serve? And, is that still actually viable or not? And so you can kind of do the analysis that previously is just too expensive to do. And so, will that get worse? I don't know. the it is a problem and will continue to be a problem, but the AI can also write pretty good code. And if you set up your automation or your agentic kind of support, you're executing manually, you can get it to fill out these dimensions of test coverage or performance, sensible performance or documentation, and you can kind of complete. It's kind of one of the things that interests me about this is that you know developers are often really good at taking things in one direction, but they need these augmentative kind of things to kind of complete the kind of picture. So what the industry isn't ready for yet is like how to interview people, how to build your skill set to be good at that, to both be a good developer and be able to have the flight of or sort of automated assistants or agentic kind of uses of agentic coding to help you fly along with that kind of process. I do believe that we should be thinking of it from productivity point of view, that you can kind of think, how can I make myself 10x more productive as a developer? Yes, that will involve spending some money. Okay, not you necessarily, but your employer normally will kind of be spending, well, I don't know, what are they going to be spending? 1,000, 2,000, 10,000 a year in automated AI assistants to kind of help you. And so the industry does shift a little bit more from being just labor oriented, like dev labor, to labor plus tools, labor plus utility costs for, and I think that's a transition. Absolutely, that's going to kind of play out in lots of different kind of ways. I should add a big caveat on all this. Maybe we can put it. This is all my personal opinion. Okay. Yes, it's F sharp community time. I'm with the F sharp community. I kind of say just personal opinions on these kind of things. And yeah, it's not nothing official GitHub here.
Noted. All right. That appears to be the last question we have in chat, but I do want to give folks just one last moment. Last question, now or never.
Okay, I want to also say I advertised this on F Sharp London as well, and so big hello to all the Londoners who are on this. We should organise a drinks in London at some time in the coming months for an F Sharp London meetup. I notice Kit is on the call. We'll get Kit up, and we will do something in person as well.
All right, sounds good. And I think we can wrap it up. Thank you very much, Don, for the amazing session. And yeah, don't be a stranger. We're always happy to have you.
Yeah, I'm in F Sharp Slack. You can drop me a message there, and you can find me online in all the usual places. And yeah, or LinkedIn as well. I also like posting there, and I've also got my blog as well. And good to